This video is on the concept of equilibrium. So equilibrium occurs when you have a reversible reaction. So a reversible reaction means that it can proceed in either direction. So this would be something like, and you've seen these before, when we have whatever reactants and whatever products, and this is when we have these double arrows. Because it can go from reactants to products, but the products can also turn back into the reactants. Equilibrium is when they proceed, so either direction at equal rates. So they're going the same speed, all right? And then your reactants and products can't escape from the system. So if you remember, we talked about this before. This means it's a closed system. So this couldn't be something where we had like a gas that escapes. Okay, so let's just talk about these systems that where equilibrium could exist. So a physical system would be when you're not actually doing a chemical change, when we're doing a physical change. Like in this case, we have a liquid turning into a gas or a gas turning back into a liquid. So when you're going this way, liquid to gas, this is your evaporation. And when you go gas to liquid, that's your condensation. So this would be something like if I had in an Erlenmeyer flask and it was closed, so sealed off, so let's say I have a rubber stopper in there, and I have liquid bromine in the bottom. Right? But then I also have bromine as a gas up here. And what will happen is the gas will turn into the liquid, but then some of the liquid will turn back into the gas. So we have both of these, evaporation and condensation, are both happening at the same time. Equilibrium would be when they're happening at the same rate. So we've got the same amount of liquid being formed as gas being formed at the same time. Now, a chemical system is when we have a chemical change, right? Or also known as a reaction. So in this example here, we've got 2HI as a gas turning into H2 gas and I2 gas, or H2 and I2 gas combining to form HI gas. So in this type of reaction, we need to note that the rate forward equals the rate reversed. So the speed, the change in concentration over time as the HI turns into H2 and I2 is the same as the change in concentration over time of the H2 and I2 combining to make HI. All right, so some characteristics of equilibrium. So this is the point at which the concentrations of all species are constant. And a key thing with this is that they're not equal to each other. They're constant, meaning they're staying the same, like their concentrations are not changing within themselves, but they don't necessarily need to be equal to each other. The rate of the forward reaction is equal to the rate of the reverse reaction, right? So the same speed, either way. It can only be attained in a closed system, because if something leaves, then it can't turn back into the other species or other substance. So it all has to stay there, because the next point is all species are present in the equilibrium mixture. You have to have them all that stay there, right? If I lose, for example, if I go back to this, if I lose some of the, let's say, Br2 gas, if this was open, the gas would leave the bottle and it would not turn them back into a liquid in that same container. So we couldn't discuss an equilibrium there. All right, and then the last point here is that equilibrium can be attained from either direction, meaning we can equal this out and make our rates equal by either adding more reactants or removing more products. We can do it either way. And the reaction then, if we just add more of one thing or the other, it will work to reestablish equilibrium. So we're going to do a demonstration in class, a little activity that will help you kind of understand this concept of this one very specifically.